Okay, good morning everyone. So we are going to talk about energy changes. Okay, for today is a relatively short chapter. Okay, so before that we can update the content page. Okay, so this would be let me see, worksheet 14 on the energy changes. This one you can write maybe 13th of April 2023. Okay, so this one is your notes right? Okay, so it's just quite a short chapter. I think I only have about, let me see, 2 pages worth, about 2 pages worth of notes. Okay, should be quite a quick video. All right. Okay, so this is chapter 15 in discovering chemistry textbook. Okay, so we want to talk about energy changes during chemical reactions. Okay, so energy, okay, cannot be created nor destroyed. Okay, according to the law of conservation of energy lah. Okay, but I won't explicitly test you this. It can only be changed from one form to another. So basically, chemical changes, chemical reaction involve energy change. All right, so depending on whether energy is released or energy is absorbed from surrounding lah. Okay, so there can be two scenario. Okay, one is whereby there's a rise in temperature. So what happens in this case is that you can see energy given out to surrounding. So we are always measuring this temperature. We are referring to temperature of surrounding. Okay, let's say you do the reaction in a beaker, then you will be recording using a thermometer, right? Okay, temperature of the mixture, okay, of the solution. That is the temperature of the surrounding. Okay, so usually if you experience a rise in temperature, energy is given out, okay, to surrounding. Okay, so this kind we call it exothermic changes. Okay, this word you can break it into two parts. Okay, exo means out. Okay, let me change a pen. Okay, exo means outside. Thermic means heat. Okay, heat given outside. Okay, all right. Okay, so if there's a drop in temperature, usually it's because energy is taken in from surrounding. Okay, so this type of process we refer to it as endothermic. Alright. Okay, so this word, if you break into half, endo means inside, thermic means heat. Okay, so heat taken in from the surrounding. So this kind you will feel the temperature drop, right? The beaker or this should feel colder, right? Okay, so don't worry about exothermic, endothermic. I'm going to properly define it in the next page. Okay, all right. Okay, before that, okay, do write your name, class, as well as date, 11th of April. Okay, so that 13th of April. Okay, so that you can do easy filing later on. All right. Okay, so this is worksheet 14. Okay, so let's go to the next page. All right. Okay, so like I mentioned just now, okay, when you break this word into two, endo means in, thermic means heat, right? Exo means out. So sometimes we say insect got exoskeleton because some of their skeleton is outside their bodies, okay, or even some shellfishes. All right, okay. So then thermic means heat. Okay, so let me see whether I want to change a pen over here. Okay, right, okay. Okay, so endothermic is a change in which heat is taken in, okay, from the surrounding. Exothermic means a change in which heat is given out to the surrounding. Okay, so in terms of what you see for the temperature is this. Okay, so normally experiments for energy changes is like this, quite basic. Okay, let's say for example okay, you measure temperature, okay, of course using thermometer lah. Okay, if you're wondering, okay, you should be using a thermometer. Okay, then you add the solid in, okay, and then you record the temperature of the water after solid has completely dissolved. Okay, so the exothermic case, you are adding NaOH, okay, sodium hydroxide. This case you are adding ammonium chloride, okay, you should know the name by now lah. Ammonium chloride. You for the exothermic one, you are dissolving sodium hydroxide. Okay, all right. Okay, so what happens in terms of the experiment data is this okay, for the endothermic case, you see a drop in the temperature. Okay, there's a decrease by 5. Okay, then for the okay, for the exo one, you actually see an increase in temperature by 6 degrees Celsius because heat is given out. Okay, so temperature should increase. But if it's taken in, I think some of them very hard to grip it. Heat is taken in, okay, temperature drop. Yeah, okay. So a lot of y'all might wonder, how come heat is taken in but temperature drop? Okay, because it's absorbed by the reactant particles, so the surrounding, okay, actually the temperature drops. Okay, so look at this case okay, so maybe you'll understand better with this visual. Okay, so for the endothermic case, okay, there will be a decrease in the temperature. Okay, there will be a decrease, okay, in the temperature. The exo case, there will be an increase in the temperature. Okay, so looking at this basically the energy conversion you are looking at, okay, is thermal energy. For the endo case, thermal energy converted to chemical potential. Okay, so this one is to the surrounding lah. Alright, okay, thermal energy from the surrounding. Right, okay, the other case, what you're experiencing is that the chemical potential energy, okay, you are converting it to thermal energy and then in the surrounding lah. So that's why you experience a rise in temperature. Okay, wait, let me write it neater. Right, okay, so that's why one, there's an increase in temperature, the other one, there's a drop in temperature. So endo, you are often experience drop in temperature. Exo, increase in temperature. So surrounding feels hot, this one surrounding feels cold. All right, okay, so when you look at the temperature graph for the endo case, normally, okay, if you cannot see this clearly, let me zoom in. Okay, so you have the temperature against time axis. So normally, let's say you start off from you start off from room temperature. Okay, this way Okay, so this is room temperature, around 25. Okay, so it will drop, reach a minimum, and then go back up again. All right, that's for endo. Okay, for exo case, it will be something like this. Okay, I'm drawing it because I scared you cannot see the diagram properly lah. Okay, but if you can see, it's fine. Then you don't need to draw. Okay, so temperature in degrees Celsius. And let's say you start off from room temperature. In this case, then against time in minutes. Okay, temperature rise, then drop. Okay, so this is what's gonna happen okay, when you give out thermal energy to a surrounding. Okay, or heat energy lah. Okay, also can. All right, so you need to know the temperature change. All right, as well as the definition of heat taken in or given out all right, okay, so let me do some highlighting. This one is heat taken in, so heat is given out to the surrounding. Okay, from surrounding to surrounding. All right, okay, then all right, okay, so endo, okay, like what I mentioned at the top, endo means in, thermic means you take in heat. Okay, heat taken in. Exo means out, thermic means heat. Okay, I'm just repeating what I have at the top all right, okay, nothing new here. Okay, so when you take in heat, essentially, let's say if you are looking at energy diagram, okay, what you have is the reactant. RXT is the reactant. Then the product will have more energy. Okay, so this case more energy than the reactants. So basically the reactant particles actually gain energy. Okay, and then the products for the exo case, okay, what you are experiencing is something like this. Okay, let's say you have the energy, your reactant is here, so what you experience is actually a drop in energy. Okay, so product actually have less energy and reactant particles lose energy, right? Okay, so you can do some highlighting again. Okay, products more energy, this one products less energy than the reactants, so essentially lose energy for reactant particles for exo, and for endo the reactant particles gain energy. All right, okay, so then below are some examples okay, of endothermic processes and exothermic processes. Okay, melting, boiling, I think is very clear to us. Okay, this case that you have heat taken in. Okay, freezing, condensation is heat given out or release. Sometimes you say release. Okay, photosynthesis, same thing, you need energy from the sun. Okay, decomposition also. Okay, for example, by heat, by light. Okay, decomposition, I can give you some examples if you would like for example copper 2 carbonate decomposition, things like this. Okay, electrolysis is also decomposition, but using electricity. All right. Okay, right, okay, and then respiration is energy given out, as well as combustion, which is actually burning. Okay, neutralization, I hope you know, is acid plus alkaline. You should have learned that. Okay, rusting even is also exothermic. Or precipitation, okay, whereby you have two solutions, you add together, it give you one precipitate, right? One precipitate, insoluble salt. Right? Or then reaction of metal with water, with steam, with acid, displacement of metal, displacement of halogen. Alright, these are all examples okay, that you have looked at it earlier on. Okay, so just to give you a few, just as a recap, like for example, potassium with water gives you potassium hydroxide plus hydrogen. That's one. Metal with water, and then maybe metal with steam gives you metal oxide, and hydrogen. Okay, all of which actually give out light, give out heat. Okay, it's very clear. Okay, or metal with acid, for example, hydrochloric acid with zinc gives you zinc chloride plus hydrogen. Okay, you can have a look. Okay, I think you are familiar. Okay, you don't need to copy down everything. All right. Okay, and then displacement of metals and halogen, these sort of things. All right, all are reactions you have seen before. Maybe fermentation is something new. Okay, don't have to be too bothered with it at this point of time. Okay, rest assured, won't test you for your mid-year for fermentation because you haven't learned it. All right, okay, it's a organic chemistry kind of reaction, whereby you use yeast to as a catalyst, okay, to turn glucose into alcohol. All right, okay, then I think that's about the end for this short chapter. Okay, less than 20 minutes video, I think.